All right, for lesson 7.2, part 2, you are now looking at an easier way to find a derivative. So we saw in part 1, we saw the first principles method. This is just another method to get you the answer, but obviously you'll see after this video, if you haven't done calculus before, this is just a much more efficient process than what we did yesterday. So you can kind of see based on the tables with some of the patterns up here, but let me give you the quicker explanation. In order to find a derivative, you take simply the exponent, you multiply it to the front of that term, and then subtract 1 from your exponent. So here's kind of the general layout of that rule. If there's a coefficient in front already, you'll simply multiply times that number. And so you'll see a few examples of that as we kind of move through the video here. So this is just kind of a big list of sample problems for how you're finding derivatives here. So again, you're taking that number, the exponent, multiplying it to the front, and then subtract 1 from the exponent. So we're going to get 7x, and if I subtract 1 from 7, my new exponent is 6. Feel free at any point to stop this video and give a couple a try before you get the explanation on them. But again, going on down the list, 6 times 8 is 48, and subtract 1 from the exponent. On these are ones you do got to be careful of. If I multiply -3 to the front, I got -3, but when I subtract 1 from -3, that brings it down to -4. So you just got to be careful with the negative signs that you go the right direction on that. Same with this one. I'm multiplying -2 times 5 to get -10. Subtract 1 from the exponent, and I'm down to -3. Same with fractions. 3/2 to the front of the problem. If you do 3/2 minus 1, and you might need to a little work with common denominators on these to make that happen, but 3/2 minus 1 would be the same thing as 3/2 minus 2/2 to create those common denominators to see that exponent. That might help. So if you have any scenarios that are not written in a simple format, simplify them first, then apply the power rule. So in a case like this, if I have a denominator for my variable, I want to bring that up top before I apply the power rule. So if I can see that as 2x to the -4th, now it's going to become just like the one we did here as we go through that process. So now I can do -4 times 2 to get -8, subtract 1 from my exponent, and it becomes -5. As far as leaving your answer in either form is okay. But check the directions. If the directions specifically say to something about not leaving your exponent as a negative, or if it's in any way worded in a form that would tell you to rewrite it this way, just make sure you pay attention to the directions. But if it doesn't say otherwise, we are okay with negative exponents. Moving on. Again, just a formatting issue. If you have radicals, it'll be easier to write those with rational exponents like this one instead. And so now you can more easily do the power rule. So now if I did 1/2 times 6, I got my term in front of 3. And if I subtract 1 from 1/2, that brings me down to -1/2. And so again, here comes a formatting issue where you can leave it like this. You could leave it like this with the positive exponent. You could also put it back in terms of a radical. All three of those answers are accepted unless the directions say otherwise. So do always check the directions, especially on a test, to make sure that you format your answer properly. But if it doesn't say, any of those three would be okay. Kind of more of the same right here. So again, I'm going to take that x to the 6th and see that as x to the -6, bring it up top. So here's the way we'd want to format it before applying the power rule. But now I would do the -6 times -2/3 and then subtract 1 from my exponent. Moving on down. Again, on number 9, what you're seeing up there towards the top here is, again, just another format. If I can see this as x to the 1/3 power. So I got this here, and then I'm going to bring that up top with the negative exponent, and now I would apply the power rule from here. When you find a derivative, there's multiple notations that you'll see for derivatives. You saw this look here for a derivative, so with the little prime notation, so that's f prime of x. That means find the first derivative. You can see it written as dy dx. That's another way to write it. Remember, this comes from what we saw in the earlier part of this chapter, delta y over delta x. That's the Greek letter delta. And so we're going to see that as dy dx. So in terms of this, if there's no y, So if you look at what you're going to see on this one, if there's no y on that, you're not going to see it written as dy dx. You're going to see it without the y. So you would see it written as d dx if there's no y involved, like this one here. So that's one way of doing it, is find the derivative. They might just say differentiate, which also means find the derivative. So these are all just different wording, but they all mean the same thing. So I'm still applying the power rule on this. So we're going to do 2 times 11 and then subtract 1 from the exponent. Same on this one. If I did 1 times 11, I got the 11. X to the first would become x to the 0, and anything to the 0 power is 1. So 1 times 11 is 11. And again, you're seeing another one here where it's just a formatting issue. Bring the x squared up top like this, and then go through your power rule, and then either this or this would be a good answer. And then last part of this, again, differentiate means the same thing as find the derivative. So again, if you just continue through the power rule, so negative 6 times negative 5 is 30. Subtract 1 from your exponent, and that's all we got to do. So square roots or fourth roots, see that as a 1/4 power, and then go through the power rule. And again, careful with the fractions. Again, you might need common denominators to work through certain cases like this. Do keep in mind on this guy that with a x to the first, that becomes x to the 0, which does not make your answer 0. That's a common mistake, is for people to eliminate the entire term just because you have x to the 0. But again, all that does is create a 1 right here, so I'm looking at 1 times 24 to get that answer.